reaction of the aldehydes and ketone reaction of 6. The third addition reaction is addition of the ammonia and its derivative. Ammonia adds readily to the aldehydes, giving aldehyde ammonia adduct. This product of the ammonia and aldehyde reaction is known as the ammonia aldehyde adduct. And these adducts are not stable and undergo dehydration to give compound containing carbon nitrogen double bond, or the amine derivatives are formed by the loss of the water molecule from these ammonia aldehyde adducts, and these leads to the formation of another category of the compound in which carbon nitrogen double bond is present, known as the mechanism of the addition of the ammonia to the carbonyl group involve the following few steps. In the step 1, this aldehyde molecule, in the presence of an acid, this proton is provided by the acid catalyzed reaction. The oxygen of this carbonyl group is containing lone pair of the electron, and this can easily attack on this proton and will accept this proton from the acid and will lead to this reversible lead to this product. Here the oxygen of this OH oxygen is positively charged because oxygen has used its lone pair of the electron, and it can satisfy its positive charge by abstracting the electron density between the carbon and oxygen double bond, pi electron density between the carbon and oxygen double bond, and here the carbon will become positive charge and oxygen will get satisfied, neutralized by abstracting these electron. In the next step, the positive charge carbon or this nucleophilic center is easily attacked by ammonia molecule. Ammonia is containing a lone pair of the electron, and this can easily attack this positively charged carbon of the carbonyl group and will lead to the formation of this structure. Here the nitrogen of ammonia is positively charged because it has used its lone pair of the electron, and this ammonia, by loss of the proton, it can leave a proton. I can write this as, suppose this is H2 and here H is, we can write it as this ammonia molecule, and this electron is abstracted by this positively charged nitrogen, and this hydrogen will be removed from the system as a proton, and nitrogen will satisfy its positive charge. In the next step, this so intermediate structure is again attacked by a proton, or this oxygen of the hydroxyl is containing lone pair of the electron. It can easily accept that proton, and the oxygen will become positively charged by accepting this proton. And here in the next step, here a positive sign is. In the fourth step, the positively charge of this oxygen is get satisfied by abstracting this bond density of the carbon and oxygen, and it will be removed from the system as a water molecule. H2O will be lost from the system, and here nitrogen will satisfy its valency by use of this lone pair of the nitrogen of the amine group NH2 group attached, and here a double bond will be formed between the carbon and the nitrogen, and nitrogen will get positively charged because it has used its lone pair of the electron, and here this nitrogen can satisfy its positive charge. Here this is two hydrogen attached to the nitrogen, and it can abstract one of the electron density of the hydrogen and will neutralize its positively charged, and this hydrogen will be removed from the system as a proton, and this amine product will be obtained from this ammonia addition to the carbonyl bond. Okay, the addition of the ammonia derivatives to this carbonyl bond. Some ammonia derivatives, suppose this is one of the hydrogen of the ammonia that is being replaced by a different group, you will be obtaining different derivatives of the ammonia. React with the aldehyde and ketone to form compound containing carbon nitrogen double bond together with the elimination of the water molecule. Here in this reaction, mainly the elimination of the water molecule between the carbonyl group and the ammonia derivative that take place, and the carbon nitrogen double bond is being formed, and these molecules are actually containing the carbon nitrogen double bond amine derivatives of the ammonia. The reaction products are usually crystalline solids whose melting points can be used to identify the aldehyde and ketone, most of which are liquid. Mostly the mechanism involve the carbonyl carbon of the carbonyl carbon is partial positively charged, oxygen is partial negatively charged, and this ammonium derivatives in nitrogen is containing lone pair of the electron that can attack on this nucleophilic positively charged carbon, and here this electron density will be shifted toward the oxygen, and this intermediate structure will be formed. Here a proton transfer reaction may occur. Nitrogen become positive charge because it has low the lone pair of the electron, and it satisfies its positively charge by abstracting the electron from this bond, and here this proton will move toward this negatively charged oxygen, and here OH group is being formed, and this is unstable intermediate structure. In the step 2, the loss of the water to give the final product. Here this structure loses water molecule to give the final product. Here the OH from this side and hydrogen from attached to the nitrogen, these two will combine and remove from the system as a water, and this hydrogen before leaving will give its electron density between the nitrogen and the carbon, and here a double bond will be formed. Okay, these are the sum of the reaction of the ammonia derivatives, and first derivative is the addition of the primary amine RNH2 group primary amine. The reaction with the primary amine give the more important substituted amine called the Schiff bases, and here the Schiff base is formed by the removal of this two hydrogen and this hydrogen from the aldehyde molecule, and amine these will be removed from the system as a water, and this RC and double bond R will be attached, and this molecule is known as a Schiff base. These are the some of example of this reaction in which the benzaldehyde and methylamine are reacted, and this lead to this intermediate structure, and in the next step this intermediate structure will lose a water molecule here from this side, and the final product is known as the benzaldehyde methylamine or N-benzyl benzylidene methylamine or Schiff base. Another reaction is the addition of the hydroxyl amine. This is the formula of the hydroxyl amine NH2OH, one of the derivatives of the ammonia, in which is obtained by replacing one of the hydrogen with the hydroxyl group. Aldehyde and ketone give oxime with the hydroxyl amine. The product known obtained by this reaction is the oxime, and here again the aldehyde and acetaldehyde and the hydroxyl amine, these two react and lead to the formation of this intermediate structure, and this intermediate structure upon removal of the water molecule will lead to the oxime molecule, and here this is the example of the ketone reaction with the hydroxyl amine. Here's another addition reaction of the ammonia derivatives is the addition of the hydrazine. Hydrazine is the compound or the derivative of the ammonia in which the hydrogen of the ammonia is replaced by the another NH2 group. Aldehyde and ketone react with the hydrazine to give the hydrazone. The main product obtained is known as hydrazone, and these are also obtained by the removal of the water molecule from these two. Aldehyde and hydrazine molecule will remove a water molecule, and here the carbon and nitrogen double bond will be formed, and this molecule is known as the hydrazone, and these are the some of the example of the ketones with that of the hydrazine. Okay, another reaction of these ammonia derivatives is the reaction of the addition reaction of the phenylhydrazine. Aldehyde and ketone react with the phenylhydrazine to give phenylhydrazone. Here the acetophenone and the phenylhydrazine will react, and again by the loss of the water molecule, these will lead to the formation of the phenylhydrazone. The same mechanism is also involved in these reaction, and the aldehyde molecule also react with these phenylhydrazine and lead to the products phenylhydrazones, aldehyde phenylhydrazones. Okay, another addition reaction is the addition of the semicarbazides, and semicarbazaldehyde and ketone react with the semicarbazide to form the product known as the semicarbazones. Here the benzaldehyde is reacted with this semicarbazide, and again the removal of the water molecule from this intermediate structure. First these two will combine and give rise to this intermediate structure, and then the removal of the water molecule from this intermediate structure, OH from here and hydrogen from here. The water molecule will be removed, and this nitrogen and carbon double bond will be formed, and the product is known as the benzaldehyde semicarbazone. And here this is the reaction of the ketone with these semicarbazone molecule and leads to the formation of the acetone semicarbazone. Same mechanism is involved from the removal of the water molecule from the intermediate. Importance of these ammonia derivatives and ammonia reaction is that these can be used as a primary reactions for the characterization of different carbonyl compounds or identification of the different carbonyl compound. The product obtained by these reaction is mainly used in these processes, and also these are particularly useful for the study of the carbohydrates because the carbohydrates are crystalline solids and they do not have melting point sharp enough to identify them. So by these products we can identify different organic compounds.